Let's take a look at this indefinite integral, the integral from -2 to 1 of e to the x over e to the x minus 1 dx. The question is, does this converge or diverge? Now, before we get started, we observe that this is an indefinite integral. Now, it doesn't have a minus infinity down here, and it doesn't have a plus infinity up here. However, it does have a singularity in the middle between -2 and 1. We see that this is a fraction. In fractions, we have problems if the fraction ever is equal to 0. If I solve e to the x minus 1 is equal to 0, that gives e to the x is equal to 1, or x is equal to the natural log of 1, which is 0. Okay, so between -2 and 1, in particular at 0, there is a singularity. The function blows up. And if I were to try to graph this function, it would look something like this. So it would blow up like this, something like this. And if so, here's -2, here's 1, and I'm trying to find the area under the curve here, but the curve goes on infinitely in both directions. And so this will require some work to figure out what this integral actually is. So to be able to proceed with this problem, I use the definition for a improper integral. So the limit as, the integral from -2 to 1 of e to the x over e to the x minus 1 dx. Okay, the first thing we're going to do is take the limit as b approaches 0 from below of integral from 2 to b of e to the x over e to the x minus 1 dx. The idea is that we pick a number b that's close to 0. I will find the integral between -2 and b, so this area in red here, and then I will take the limit of that as b gets closer and closer to 0. The second part of the limit will be the limit as a approaches 0 from above, integral from a to 1 of e to the x over e to the x minus 1 dx. The idea is that I take a number a that's close to 0, but greater than 0, find the area between a and 1, and then let a get closer and closer to 0 to try to find the area in green. So that's setting this up with an improper integral. Okay, now to do both of these integrals, I will employ a u substitution, and I'll do that u substitution over on the side. I will let u be equal to e to the x minus 1, so that du is equal to e to the x dx. And so I've got both integrals set up for this. Now the catch is that I have to worry about the endpoints, and this proves to be a bit of a mess. If x is equal to -2, then when x is equal to -2, u will be equal to e to the minus 2, 1 over e squared minus 1. And if x is equal to b, then u will be equal to e to the b minus 1. And so employing the substitution for the first integral, we get the limit as b approaches 0 from below, integral from e to the minus 2 minus 1 to e to the b minus 1 of e to the u du. I'm sorry, I wrote that down wrong. Du over u. So the denominator here becomes u, and e to the x dx is my du. So I apologize, I misstated that. Plus, second integral, limit as a approaches 0 from above. The integral is going to look very much the same, integral of du over u. The denominator is u, e to the x dx is du. The one thing that's going to be different is that I have to worry about the endpoints. So if x is equal to a, then u will be equal to e to the a minus 1. And if x is equal to 1, that means u is equal to e to the first minus 1, so e minus 1. And so I have the endpoints. The lower endpoint is e to the a minus 1, and the upper endpoint is e minus 1. Okay, so now I can evaluate both integrals. The limit as b approaches 0 from below. The antiderivative of 1 over u is going to be the natural log of absolute value of u. And I evaluate that from e to the b minus 1 on top and e to the minus 2 minus 1 on the bottom. Second, we have the limit as a approaches 0 from above. Once again, natural log of the absolute value of u. And the upper limit is e to the minus 1. The lower limit is e to the a minus 1. Okay, so now I have these two integrals to calculate. The first limit is going to be the limit as b approaches 0 from below of the natural log of absolute value of e to the b minus 1 minus the natural log of 1 over e squared of minus 1. And then the second limit, I'll just write that on the second line so that I don't get too squeezed over here. Limit as a approaches 0 from above. The natural log of absolute value of e minus 1 minus the natural log of the absolute value of e to the a minus 1. Okay, so now I have to compute the limit in red and separately compute the limit in blue if I can. If I can, both of those limits converge, then the integral converges. If either one diverges, then the limit does diverge, the integral diverges. In particular, I'm not allowed to try to cancel these two things here. I needed to compute the limit in red separately, and then I need to compute the limit in blue separately. Now, so let's take a look at this. Well, obviously that's a constant. So there's no b's in this, so that doesn't go anywhere. Let's take a look at this all by itself. What happens to natural log of absolute value of e to the b minus 1? As b approaches 0, so let's take a look at this first limit. As b approaches 0, e to the b minus 1 also approaches 0. E to the 0 is 1. 1 minus 1, that goes to 0. Okay, and so the natural log of absolute value of e to the b minus 1, that diverges. That goes to minus infinity because natural log of x goes to 0 as, natural log of x goes to minus infinity as x goes to 0. So as b goes to 0 from either above or below, e to the b minus 1 goes to 0, and the natural log of something that goes to 0 blows up negative to minus infinity. So the first limit diverges, and thus the improper integral also diverges. Okay, and I could also figure out the one in blue, but there's no point. One of them diverges, and therefore the original integral also diverges.